Okay, so the next kind of big formula we need to talk about here then is slope. And slope is one of the kind of biggest properties really that we have as part of our coordinate geometry of the line and our equations of the line. And the slope of a line is a measure of how steep the line is. We can see that up the top here. So the slope is a measure of how steep the line is. Basically tells us how much or how far the line goes up as I move from left to right. So we always kind of consider going from left to right when we're looking at these lines here, and it's really just telling us how kind of what's the relationship between these moves and these coordinates here. And we have two different methods for calculating slope, and on top of that then we can also use the equation of the line, which we'll look at in one of the later sections here. We're going to focus, I suppose, first of all on these two kind of distinct methods. Both are important and both have their own merits and their own potential uses, so it is important that you're familiar with both. The first we have is straightforward formula. Okay, labeling our points as we did with distance, as we did with midpoint, x1, x2, or x1, y2, x1, y1, and x2, y2, labeling our points appropriately there, filling them into the formula as normal. And really what we're looking at here is on the top, y2 minus y1, that's the change in y over the change in x. So we're looking at maybe how does the y coordinate change, how does the x coordinate change. So looking even at the diagram we have here, it goes from 2, 3 to 4, 2. So looking at maybe how the x coordinate has changed there, I've gone maybe from say 2 minus 3, I've gone down minus 1, and then from the x coordinate then 4 minus 2, I've changed 2 there. So a slope of minus 1 over 2, just filling in my points as we would do normally. Okay. The alternative method we have then is to use a kind of graphical method. And the little kind of way we have of remembering that is this here, rise over run. This is quite important here. And I've put a note at the bottom, which again is also quite important for us, is that we have to have clear, reliable points in order to use rise over run. So we have to be able to look at the points and know their value. And we pick 2 points on the line that we can clearly see, and we work out how to move from one point to the next, always moving from left to right. So looking at the point here that we have point A is 2, 3, I can see that I need to go down a distance of 1, so minus 1 here, and I need to go across a distance of 2, so plus 2 because I'm going to the right. So down a distance of 1, across a distance of 2, so my rise over run is minus 1 over 2. And we could even consider that here to be a fall as opposed to a rise. It's a negative rise and going down the way as opposed to going up the way. So both giving us the same answer, both essentially resulting in the same sum, but in some cases rise over run may be easier for us to visualize, maybe easier for us to see. We may not have all the coordinates. In other cases, if we have the coordinates, just doing the slope out properly is probably a bit easier for us, but it can be kind of down to you and down to your own judgment doing the question, but you should be familiar with both. Okay. So continuing on then to some extra properties of slopes. So we said a slope is kind of a measure of how steep the line is, essentially nearly kind of what direction or angle it's going in. And the two, I suppose, specific or important types we have within that are parallel lines and perpendicular lines. So parallel lines, we should remember hopefully, are parallel lines are lines that move in the same direction, they'll never meet. Okay, we think of those two L's in the center of the word kind of representing parallel lines. And if two lines are parallel, they'll have the same slope. So they're essentially going at the same angle and they're never going to cross over each other. So we can see from the diagram there, two parallel lines both working out with equal slopes. If lines are perpendicular, perpendicular means that they meet at 90 degrees. Okay, so meet at a right angle. If two lines are perpendicular, then their slopes will multiply to give minus 1. Okay, so that's kind of the key check that we have for perpendicular lines. Their slopes should multiply to give me minus 1. And to go further with that, we say that they're opposite reciprocals. Okay, which is kind of a very fancy maths term for saying that if one slope is 3 over 4, then the other one would be minus 4 over 3. So we flip the fraction and we change the sign. So the reciprocal part is actually the part that refers to flipping the fraction, and then opposite obviously kind of changing the sign there as well. Okay, so if they're perpendicular, it's the complete opposite. So flip the fraction and change the sign. If they're parallel, they're just going to be identical. They're going to have exactly the same slope. And that's really important and something that we're going to come back to in one of the later sections here as well. The last thing then, I suppose, that we've kind of touched on briefly, but just to make it a bit more explicit there, is if we're going from left to right and the slope is going up the way, then we would consider that a positive slope because I'm moving upwards, I'm rising positively. If I'm going down, that would be a negative slope because I'm essentially falling or rising negatively. So let's calculate the slope of this given, these two given points here. We're using the two methods we have, so slope and our rise over the run method. So let's try and use our slope formula first of all. So I'll pick out my 2 points, which are 2, 3, and 3, 1. I'm going to label them as we did before, x1, y1, and x2, y2. M equals y2 minus y1 over x2 minus x1, filling in my values here, 1 minus 3 over 3 minus 2. So that's going to give me minus 2 over 1. Okay, so just nice straightforward slope of minus 2 over 1 there. That's my slope for this equation. Okay, let's just verify that, I suppose, using our rise over run method over here. So we're going to look at how do I go from one point to the next here. So going down here, I'm going down a distance of 1. Okay, so I'm going to be, or excuse me, I'm not going down a distance of 1, looking at the wrong coordinates there. So I'm actually going down a distance of 2, so minus 2 here, and then going across a distance of 1. So for every 2 that I go down, I'm going over 1, or alternatively the other way around, every 1 I go over, I need to go down 2. So using my rise over run here, that's going to give me an answer of minus 2 over 1. And we should know that any fraction written as minus 2 over 1, any fraction written over 1 can just be written as the number itself, minus 2. So 2 different methods of kind of answering there, but both getting to the same answer. So whether we use our kind of formula or a rise over run method, we're resulting in the same answer either way. So let's just kind of jump into maybe some of the questions here. Really, some of these first few ones here are really just practice of using that formula. So we might try maybe the last question here and maybe one of the first exam questions. So let's look at this second example here. I'm going to label my points x1, y1, x2, y2. I'm just working out the slope here. The letter I use for slope is M. Okay, one of the things actually I should have emphasized a bit more at the top there. The letter we use is M here. Kind of unusual, but definitely one to watch out for. So M equals y2 minus y1 over x2 minus x1. So let's fill in the different values that we have. Minus 7 minus 6 over x2 5 minus 2. Okay, and we'll put the minus 2 in brackets there so that we can account for that negative sign. So minus 7 minus 6 over 5 plus 2. So that's going to give me minus 13 over 7, and I can't simplify that down any further for myself unless I write it as kind of a mixed fraction there. But minus 13 over 7 works absolutely perfect for me. Looking then at one of the exam questions here, it says show that the line containing the points 3 minus 6 and 7 minus 2 is perpendicular to the line 5x minus 9y plus 6 equals 0. Okay, so we're getting into kind of some two different parts here really. So we can see an equation of a line here, which as I said we might look at more in one of the later sections, but feel free I suppose to come back to this question maybe when we've looked at that a little bit more. But we can start off anyway by finding the slope of the 2 points that we do have here. So again, starting off by just writing out my formula, y2 minus y1, x2 minus x1, filling in the various points that I have. Y2 is 12, x2 minus 7 minus y1 minus 6, and x1 3. Okay, seeing if I can simplify this down, then 12 plus 6 over minus 7 minus 3 here, and that's going to give me 18 over minus 10, which will reduce down to minus 9 over 5. Now, when I have the equation of the line written in this format, what I want to do is I want to rewrite it into a format where I have y on its own. And again, as I say, this is something we look at in the later section on equation and line. So isolating y there, I'm going to bring it over to the right hand side so that I only have to move over y, and I can divide by 9 to get y on its own. And when the equation's written in this format, I only need to look at the coefficient of x here. So we can see if I match it up to the right hand side, I'm using the letter m. We've said m stands for slope, so I only need to look at that coefficient to tell me what the slope is. Since I want to show that these are perpendicular, the tool I need to make use of is that they will multiply to give me -1. Now by looking at them here, I'm kind of thinking it is going to be correct because they do seem to be those opposites of each other. So opposites in every way, upside down, and signs are different, but we can just double check and see that we get -45 over 45, which gives me -1. Okay, so we've shown that the slopes are indeed perpendicular to each other. And that last little step, I suppose, is us just showing that explicitly, showing that they definitely are perpendicular. So the main things really for this section is, I suppose at the start here, are two different ways of calculating slope. So whether that be formula presented to us in the Formula and Tables book, or rise over run, and kind of making sure that we're confident and able to use both of those methods for calculating our slope.